to have this uploaded, and you can go back and look at it later on. If you have any questions, please use the chat function or the Q&A function, and I'll come back to have a look at those. And periodically, I will stop to check on how we're actually progressing in terms of the overall presentation. So a little bit, I guess, of housekeeping in terms of where we're sort of looking to start in terms of doing this. We have been for a long time working to try and increase the awareness and understanding of Breedplan, which is one of the very important selection tools that is available in the beef industry. And while we've been working to try and encourage people to understand Breedplan, what we have found has been that the level of awareness and really good comprehension about how to use Breedplan effectively in a business has been probably not as great as we would like. So today I wanted to not spend a huge amount of time, given that we've really only got an hour, to go through everything about Breedplan, but really to start to address some of the basics to help you effectively get to grips with Breedplan. And so today what we'll be looking at doing is a couple of things. First of all, we'll be going through and refreshing some of the basics that are important to understand how Breedplan works in the background. And knowing that there is a very good system in the background, making the data that is collected and inputted into the system work effectively is important to be confident in your ability to use Breedplan efficiently. I'm then going to talk a little bit about where Breedplan fits into your program, and also to highlight a couple of things that have come through, some of the questions that have come through earlier on today, in terms of understanding linkages and reference populations, the importance of accuracies of an EBV, where genomics and indexes fit into that process. So thank you for taking the time to be part of today's session. We actually have over 117 producers were enrolled in today's session from across Australia and also internationally. So for those of you who I haven't met, which is probably most of you, my program or my background is based in as a specialist providing beef advice, and I have clients across Australia. Prior to commencing with my own business, I was a beef extension officer with the New South Wales Department of Primary Industries for 17 and a half years. I also write the genetics columns for Beef Central, and I sit on the RAS of New South Wales and on the Cattle Council of Australia with their Pilot Policy Council. The types of things that I actually spend my time doing is my agency role, where I work in conjunction with an agency in Inverell, Bob Jemison Agencies, as well as doing a lot of Auctions Plus assessment. And then for my clients, I spend most of my time working directly on their program to find ways to make their programs occur more efficiently and to find ways to make a little bit more money for them each year. This session, I really do need to acknowledge very much the support of Breedplan, who have provided quite a lot of material, and also the SBTS and TBTS, which is a Southern Beef Technology Service, and the Tropical Beef Technology Service, who actually are one of the great resources that we have to help you understand Breedplan and to make better decisions around your genetic selections. The MLA Genetics Hub, which is a newly created hub, is something that I'd encourage all of you to spend some time looking through after this session, to have a look through and understand what resources are there, and also to go back and cover any topics that we might have moved through a little bit too quickly today. Angus Australia also has a terrific resource of availability of data, recording systems, but also advice on how to understand EBVs, particularly related to Angus cattle. But given that most of the EBVs that are being recorded and reported by Angus Australia are also shared by many of the other breeds, it's a very good way to get your head around some of the specifics related to the traits that are reported in Breedplan. I'd also like to thank Dr. Matt Walcott and Dr. David Johnston, who work for AgBoo in Armidale. They are the real gurus of the Australian beef industry, and particularly in terms of genetic progress. And they are my go-to people to answer the difficult questions. And they've helped a lot with this presentation as well. So what we might do is we will just get underway a little bit. I'll just check to make sure that no one has actually got any outstanding questions at this stage of where we're actually up to. I can't see any that appear to be there, so that's fine. What we'll do then is continue to move along and work into, I guess, that basic level of understanding that we require, which is to understand this issue around two really important parts of if you like, genetic progress. And the first is that we need to start thinking about and understanding this concept of heritability. And heritability is something we all talk about, and it's designed, I guess, well, design's not the right word, but what it describes is the level of transmission of particular genetic traits from parents to the progeny. And so something that we call to be a highly heritable trait says that it's a very strong influence on how that's expressed within the progeny. And the environmental impact on how that gene or that trait might be expressed is probably less is less well influenced by the environment because of that strong heritability. Whereas something that we talk about being low heritable, a lowly heritable trait, really means that the environment is going to have a very big influence over the expression of that trait and how you might see it occur within your animals. So not all traits are very strongly passed on. They're not very highly heritable. Some are there, but the environment can actually have a greater influence over how that might appear within your herd. So when we look at things like heritability, and I guess probably why is it important, we talk about it being on a range of 0 to 100%. And so what we're really looking to try and account for is that proportion of the variation, the genetic and environmental variation that is due to those genes being expressed. And in practical terms, things like reproductive rates tend to be fairly lowly heritable. And if you think about it in your own environment, that would make sense because nutrition, fat score, other environmental influences really do also have a big impact upon fertility rates within your herd. Whereas growth traits tend to have a more moderate heritability and fairly readily expressed by animals. And carcass traits tend to have some of the reasonably high levels of heritability. So if we looked across at this chart on the left-hand side of your screen, you'll see that things like carcass and meat quality, some of the heritability influences on carcass weight are very high, 45%. Rib fat is quite high, 30%. Meat yield, 45%. So there's a very big influence from the parents of those particular progeny on carcass traits, whereas things like pH or butt temperature, which are influences that occur post-slaughter, you can see really have very little heritability at all, and so are very influenced by what happens within the chiller. If we looked at within our breeding herd, things like calving ease tend to be a lowly heritable trait, whereas birth weight, cow weight, hip height, and even things like coat length are very heritable traits. And so it's important to know that in the background of when we start to collect data, we're starting to think about how much of that impact on the expression of those animals is the result of the heritability of those particular traits, and how much is it maybe potentially due to environmental impacts. There's also a bit of a variation between breed types. And so if you have a look at this chart, this is one that shows, again, very similar ranges of heritability, but you'll notice that there is a little bit of a range between temperate breeds and our tropical breeds. And so there is the opportunity, again, for us to think about how we might use genes and the heritability of those within our programs to address particular production requirements within our herd. So heritability is one of those things that people will talk about quite a lot. And really what you need to take away from that is that expression and the degree that it's expressed within the progeny, depending upon environmental impacts. The other part of what we talk about is what we call correlation. And correlation really is the I guess the influence of how traits are expressed by the different genes that an animal possesses. And so the interaction of how those genes occur across traits can either be very positive or very negative. And positive or negative is maybe not a great way of actually expressing something, because a positive correlation really just means that we're changing, I guess, the direction of a trait. So if you have a look at the chart there on the right, on the left-hand side, a positive genetic correlation means that within those two genes, that are being measured within that animal, there is a strong relationship that says that both of those are likely to increase um, over the expression of how that animal is seen and observed and recorded. Whereas a negative genetic correlation, you'll see that there's less of that expression. Now, positive or negative is not necessarily a bad thing or a good thing. I guess that probably what we're looking to try and think about is, if we're selecting for a trait, what is it correlated to? And will it have an impact on something else that's going to be important within our breeding program? And so, if you have a think about some examples of correlation, and we'll take I guess, a positive correlation in terms of milk production. One of the things that we would find if we selected more for milk production is that we'd also start to increase the amount of energy that our animals require on a daily basis. And the impact or the magnitude of that on production system would be what we consider to be a fairly moderate impact. Carcass weight, as another example, would also have a positive increase in birth weights. And so there would be plenty of people who would say, well, that's not necessarily the effect that I want to have. I don't necessarily want to increase birth weights while I'm increasing carcass weights, but that's the effect of a correlation. And knowing what those correlations are and the effect of correlations is important within the calculation of how Breedplan uses the data that we record and submit into the system. So when we start thinking about this concept of genes, and I guess the problem is that when we're looking at an animal, what we're really looking at is the impact of a couple of things. The animal that we see, the performance or the phenotype, if you like, is really the result of the genes that were given to it by its father and by its dam. So 50% from each, and it's set at conception. And no matter how hard you'd like to try and fiddle with that, you really can't do anything about it. The other effect then is the production system. What was the nutrition, the health, the management, the processing, or the post-slaughter impacts that occur within the traits that we're interested in, or the productive system that we're after? And one of the challenges for a lot of people is that looking at an animal, if we looked at that phenotype or that performance, we don't really know how much of that is the result of its genetic potential, how much is it because it's been influenced by an environment. And you can't really pull the hide back and delve down to look at that. And so, what we're really starting to think about when we're looking to compare animals is, what is the genetic influence that those animals are going to have in my environment and in my system? And EBVs are part of that in terms of estimating the potential breeding value of what that animal will contribute to your herd. And so if we look at that picture again in terms of performance equals, or phenotype equals genetics plus environment, within Breedplan, our generation of an EBV is really, we're trying to look at the equation, which is performance less the environmental impact. And so what we're trying to take away is the impact that the environment, be it management, nutrition, location, has had on how those genes will be expressed. That gives us then the greatest opportunity to estimate the potential breeding value of that particular sire or that dam in a breeding herd that could be in Tasmania or could be in North Queensland. So Breedplan uses a system which we call BLUP, which stands for a multi-trait analysis, the best linear unbiased prediction. And there are plenty of people who wonder whether Breedplan is the best system in the world or not. Quite frankly, it is, because it takes into account an awful lot of things that other evaluation systems don't necessarily include, particularly the heritabilities and the correlations of traits that have been expressed or measured over a number of different herds, but also the reference population, which I'll come to shortly, that those animals are being compared against. So an EBV is basically calculated using the performance records of individual animals, taking into account fixed effects, so the environmental effect at different locations, as well as the pedigree and other information that we know about those animals. So it's everything that you can think about: sibling performance, progeny performance, parental performance. And that analysis allows the creation of EBVs or breeding values for most of the productive traits that we're looking at. So that's a little bit, I guess, of the background to where we came to today. And one of the questions that I asked for ahead of this survey was, how confident were people in their knowledge of the traits reported in Breedplan, and how confident were they in understanding how they were recorded and used? And there's quite a lot of people who weren't as confident in either their knowledge or how the traits were actually recorded and used. So we'll spend a little bit of time looking at that. So an EVB is effectively, in simplest terms, describing the level of genetic merit for particular traits displayed by animals. And we can never really estimate a true breeding value. A true breeding value is 100%, and that animal will do what we expect it to do every single time. But those estimates can become very highly accurate and very close to 100% of, or close to true breeding value, if we include more and more data based on performance records, which is the raw data that you collect and record, as well as the data from pedigrees and from relations, as well as other information. And we express our EBVs and in terms of the difference between the animal's genetics and the genetic base to which it's compared. So unfortunately, at this stage, we can only compare EBVs within a breed. So you can't compare Angus against Brahman, Brahman against Droughtmaster. However, we are working towards things such as the Northern Repronomics Project and the Southern Multibreed Project, where we can start to look at comparing those animals on a similar baseline. The EBVs themselves are reported in units in which the measurements are taken. When you look at an EBV, it'll be expressed in things like kilograms or centimeters or intramuscular fat as a percentage. And remember, the bull that you use, half of his genetics will be in his progeny. The other half are going to be contributed by the dam. So when you look at an EBV, you really need to remember that what you're looking at is going to be half of that figure on the EBV sheet. And I'll come back to that shortly. Our EBVs are really now growing to become available for most of the production traits. And it's very, very difficult to find an EBV that hasn't been created or used in order to give producers greater opportunity to assess the genetic breeding value of that animal to contribute to things from docility and flight time through to growth traits, soundness traits, as well as carcass and reproductive traits. So there are EBVs for most of the traits. Some breeds have much more than others. Some breeds that are just new within the industry or are starting out are still recording a lot of their raw data to submit for calculation, whereas someone in the Angus breed would be very familiar with a huge range of EBVs that are available. In its simplest terms, an EBV is designed to help us address how we might actually think about making a decision to make some genetic progress within our herd, to look to improve. And so we can compare two animals taking away from that the environmental impact that those animals have had, so that we're considering just the genetic breeding value of that animal and how that might contribute with your herd. So if you look at this example, we've got two bulls here, a bull with an EBV of plus 60 and a bull with an EBV of plus 40. So if you joined those bulls to those cows, one of the first things to remember is that only half of that genetic potential is going to be passed on by the bull. So effectively, bull A has an extra 30 kilos of growth potential that he could offer to his progeny, compared to bull B, which is going to be about 20 kilos. So when we look at 200 days at the progeny from the bulls that were born from bull A versus bull B, what we would expect is that there should be a 10 kilo difference, because we look at the difference between 30 and 20, which is half of what both bulls have contributed, which gives us that 10 kilo difference between those animals. And so if you're looking at a very simple level to try and improve one particular trait or a level of growth, you can't just look and go, well, I'll pick bull A because he's got 60 kilos. He's got to be better than bull B. You need to think about how that is going to be on average across your herd. And the other important thing is to remember that this is on average across your herd. So there will still be some genetic variation within both groups. Remember, the dam has contributed 50% to that herd. But on average, we would expect that anything that was joined to bull A will have an average calving weight, an average 200-day weight that's 10 kilos heavier. So we move, I guess, in terms of this concept about developing an EBV. And part of this is this description about what is going to be passed to progeny. And we depend upon the linkages that we have between the animals on the farm with other animals within the breed in other locations. And so if we have a look at the graph up on the top right-hand side, and if we were looking at the average yielding weight of progeny, if we looked at bull A, his average yielding weight somewhere in the order of about 310 kilos or so. But bull B, by virtue of living on an irrigated farm where the seasons are never really against him, is going to allow that environmental effect will have the greatest opportunity to allow the genetics to be expressed. So of course the average yielding weight of those progeny will be heavier. Bull C on a dryland farm but in a better area will be somewhere in the middle of those two bulls. Now, making a head-to-head comparison is always going to be a little bit of a tricky thing there, because how much of that is environmental effect? Now, to some degree, we can make some estimates based on the degree of heritability for growth. And you remember that I talked about heritability, and we know that it's probably in the order of, say, about 30%. So we could say with some confidence, but only a slight degree of confidence, how much of that would be genetic and how much of that would really be environmental. However, if we were to introduce another bull, so we introduce what they call a link sire, which in this case is the red square boxes down here. This bull is used across all three locations. And he gives us the baseline that allows us to do the comparisons, and so takes away the environmental impact that we're seeing expressed across those three locations. So while you can make some direct progeny comparisons between properties, you can also make some indirect progeny comparisons across the locations due to those links. And remember that the EBVs, when they're calculated, are always going to be twice what the direct progeny comparisons are, because the direct comparison is that 50% result of the sire effect and the dam. So a linkage allows us to be much more confident in understanding the breeding potential and the breeding value that bull or those bulls have brought to the program, taking away the environmental impact. So EBVs tend to be a very good way of assessing what you're seeing in terms of its impact from environment and genetics. But those EBVs are estimates and will be adjusted on a range of different things. First of all, we know, and I've talked to you before about heritability. So if we know the heritability of the trait, that will help us make some adjustments. So your basic raw scores that you might submit starting out in Breedplan would allow you to generate some EBVs. And they would have some degree of accuracy, but they'd probably be heavily influenced by the heritability of the trait. If we didn't know very much about the parents, so their EBV accuracies were low, then those estimates are also going to have a low degree of accuracy and you'd expect them to change. But if we knew a lot about them and they'd been a highly used group of sires and we had lots of progeny and lots of genetic linkages, we could be reasonably confident that based on the heritability and the performance records, that we would expect those breeding values to be pretty good. The amount of performance information available. So this is one of the big things that a lot of people have asked is how much data do you need to record? The more data you can put into Breedplan, the more accurate we get to have a prediction about what performance has been, taking into account then the environmental impact. And so we really need to think about having as much information going in rather than less. I guess the other side effect with that is how effective is that information? And today I won't spend as much time on talking about this, but how you run your animals and keep them together. So how do you run your contemporary groups so that everyone gets a fair crack at the same environment, so we're all on the same base, and so the variations that you measure at 200 days or 400 days is directly resulted of the genetic expression of that trait rather than the fact that you had bulls in 3 different paddocks on 3 different locations. And finally, the correlation with your other traits. And remember, knowing that correlations do occur with traits can allow an increase or decrease in an EBV as we get a little bit more information that has been measured on some of those other traits because we know that they would be correlated. So when we think about this, we have a look at correlations. And a correlation can be used as part of that development of an EBV for a trait. So if a genetic correlation is a fairly low one, so the two traits are not closely aligned, the difference in the accuracy of that EBV is going to be really quite big. And that makes sense. If there's not much of a relationship, you can't really expect a huge amount of accuracy. But they become very useful, and particularly, and I know that that there are some people from more extensive areas joining today. The correlations can be quite a useful way of recording traits or information when it's very difficult to record a specific trait. So things like birth weight, for example, can be quite a useful um, tool for a lot of people, a level of information that they require. But if you're not able to record birth weight when it is supposed to be recorded, then we can rely on correlations using that known data to start to give us some degree of accuracy around that specific trait. So if you like, we look expected on this table is the expected birth weight accuracy if we didn't record birth weight. And you'd expect that it's going to be fairly low at about 40%. If we're able to correlate that with other information, so maybe 200-day weight or another trait that was also correlated with birth weight, that degree of accuracy is going to start to come up to close to that 60%. And certainly if you were recording birth weight, it's going to be much higher than that 60%. So knowing that there's a correlation there can allow producers to actually generate and develop EBVs, even if they may not have specifically measured the trait. So one of the questions that people ask is, how can we have an EBV if we don't measure it? We can have it and generate it because of the correlations. However, we'd expect that the accuracy is going to be reasonably low because you're really just depending upon that known knowledge rather than the actual performance data of the animal. And therefore, it's likely to change. So if I move across to I guess this concept of accuracies, because this is the other, I guess, key understanding within an EBV. Your accuracies are something that we all should be thinking about when you look at a breed catalog. When I asked the question prior to this webinar, do you understand and consider accuracies? It was close to 50-50. And I was a little bit surprised about that. I tend to look at accuracies pretty well religiously, because one of the things is that the higher the degree of accuracy, the more confident, the closer we actually are to true breeding value. So an accuracy is really going to reflect the amount of information that's been collected on that animal, or on that animal's pedigree or relationships, that really then will be driving the EBVs that I look at. So if you were to look at accuracy and have a look at that reporting on an EBV or a Breedplan program or a bull sale catalog, you'll see an accuracy score. Knowing that something is less than 50%, it's really a preliminary EBV, and it's going to change. As those sires are used, as those pedigrees are used more extensively and more data is collected, we would expect that that will improve the accuracy of that EBV. Now, that doesn't mean that the particular trait EBV will improve or decline. It just means it's going to change. It's probably going to do one of those two things, go up or go down. That's not a bad thing. In fact, that's a good thing, because it means that you're going to have a much more accurate prediction of the breeding value of that animal. 50 to 74% accuracy, the EBVs are medium, and there'll probably be a little bit of movement and variation within that range. And then once we get over about 90% accuracy, it's very unlikely that that's going to change. And so you would expect that that animal's true breeding value is really what you're looking at, is what you would expect to happen on average across your herd. So when you start to look at some of those EBVs, you'll probably notice that the younger animals that don't have as much data or relying on correlations are going to be down in that low area. And as we get more information, accuracies are going to start to increase. So when you look at a particular catalog, and this is just an example, it's not necessarily that that I'm actually after a particular breed or anything like that, but it's a really great way to have a look at our EBVs that are here. And what you'll see is that the accuracies are actually reported for each trait. So for calving ease, we see that these are fairly low levels of accuracy. So we're either relying on correlations that have happened here, whereas something like gestation length and birth weight, there's quite a huge amount of information that's been recorded, obviously on parents, on siblings, and so on. One of the other important things besides the accuracy is to have a look down here where this arrow is, to have a look at the traits that have been recorded. The producers that have this animal have actually recorded things such as birth weight, 200-day weight, 600-day weight. They've measured scrotal circumference, and they've scanned for eye muscle area, for rib and rump fat, and eye muscle and intramuscular fat. They've also done structural assessment, and they've collected genomic information. So when you look at the traits that have been observed, there's quite a lot that are going in to contribute to those EBVs, which explains a high degree of accuracy across many of those traits, and would also explain to some degree why some of those other traits, such as calving ease, are a little bit lower when you compare them. And it's because they haven't been directly reported and observed. And so you are reliant on the correlations and the heritabilities of those particular traits. Now I'm going to just pause for a second and stop sharing for 1 second to see how we're going for questions. I see any raised hands or anything like that. In terms of where we actually are, is everybody reasonably comfortable? Doesn't seem to be any key points, so I will continue to go back to sharing the screen and moving along. So when we look at the actual traits that are recorded in an EBV, rather than looking at this particular graph, what I'd suggest is we look at here our traits and what they might mean. So there are things that are fertility traits, such as calving ease. The calving ease direct is what we're talking about on the level of intervention that's required to help a 2-year-old heifer calve unassisted. And so it's a particular interesting trait for a lot of people who are thinking about joining heifers or looking to improve their fertility rates within that particular group of females. Calving ease on daughters is looking at the calving ease measured against those 2-year-old heifer daughters when they go to have their own calves. So our direct calving ease is how easy is that calf going to come out of that cow after the bull's been joined. And the second one, which is calving ease on daughters, is how effectively are those replacement heifers able to calve unassisted as a result of the genetics that we've used. And they're two quite handy EBVs to look at, particularly if you're thinking about replacement females and keeping replacement females within your herd. Some of the other production traits that we have, we've obviously got growth traits measured at 200, 400, or 600 days. We have our mature cow weights that are measured on our older and mature cows. Days to calving, which measures the length of time between when a bull is joined with cows and when conception occurs, and then when the calf is actually born. So that becomes also quite a useful tool in trying to think about which females are likely to start to return to estrus more quickly, and so conceive more quickly in the joining period, and so have heavier and more valuable calves for us to sell in the following year. Gestation length, also quite happy, but quite useful, particularly when we know conception dates. And so that becomes a useful trait for a lot of people thinking about their particular programs. Now, rather than go through every individual EBV, I think that it's important that you spend some time thinking about what EBVs are available within your own breed, but also which ones are important, and thinking again about the fact that if you select for a single trait, so let's think about for a second this concept of growth here. We know that growth is positively correlated to mature cow weight. So if you start to select for growth, what you will start to end up doing is increasing the size of your mature cows, which means that you'll increase your feed demand and eventually get to a point where you may be running less cows rather than the number that you might have been doing 10 or 12 years before. And so it is important that we start to think about what is the impact of some of these traits and not use what we call just single trait selection. The other, I guess, key point about this is thinking about those traits that matter to you. And if you're a seed stock producer, how you record and make sure that you're providing enough information to start to identify those animals that don't necessarily fit that traditional curve. So you may have heard people talking about a curve bender bull, and he could potentially be a bull that has got above average levels of growth, but has a smaller mature cow weight. But if we don't measure a lot of mature cows, we won't really know where they are in the program or where they fit within the broader breed. The other, I guess, exciting development is the idea of being able to actually use genomic information. And people have asked about genomics, and does genomics mean that we won't actually have to record some of this data anymore? Well, sadly, I'm going to disappoint quite a few of you. I guess that really the exciting thing about DNA and genomic information is it allows us to collect a lot more information on animals. And particularly given that we know what the genes are, we can identify whether animals have those traits at a younger age and start to think about whether those are animals that we will continue to keep and to grow on and use as sale animals. And it also allows us to improve the accuracy of our EBVs. So while phenotypic information, the performance data is important, genetic information allows us to start to identify some of those animals a little bit earlier and make some more effective decisions prior to, I guess, that later point in time. So it can speed the process up a little bit, as well as actually making everything much more accurate. So a genomic SNP or a genomic test that gives us information used within an EBV does quite a lot to help improve or enhance an EBV's accuracy. So if we looked at something, and we go back to, again, if you like, that question about birth weight, where we didn't record birth weight, and we didn't, and we were relying on correlation, and it was sitting at about, I think, 30% accuracy. If our initial accuracy was about that 30%, using genomics, it's going to significantly start to increase the accuracy of that EBV for us for that particular trait. Some of those other traits where we might have some initial accuracies based on a little bit of limited data, some pedigree knowledge, and so on, having the genomics of that particular animal included in the EBV run lifts that EBV's accuracy quite high. And this has got quite a lot of appeal, particularly for seed stock producers who are looking to generate EBVs for younger bulls who haven't had the chance to have progeny on the ground and have got a limited background in the reference population of sires that are linked to help them create a more accurate EBV. So genomics does enhance and improves accuracy across the traits that we're interested in. But the important thing about having genomics is not that we're actually taking a sample. What we're really relying on is using the known relationships between animals that are within the broader population, what we call the reference population. So if we're able to use their known relationship between both their physical performance, their phenotype, and their genotype, that gives us a greater opportunity to then start to generate EBVs for younger animals. But if we're not using the reference population, or we're not linked to a reference population, then what you do is you've ended up creating, I guess, a genetic data sheet, but it doesn't really tell you where those animals fit within the context of the broader breed. So while your animals might come back with a fantastic score or a fantastic rating for particular traits, does that mean that you're breed average or better than breed average, or are you still below breed average? Without being linked to a broader reference population, without knowing where those animals fit, you've probably limited your capacity to actually make the most out of genomics. But where it starts to become quite useful is in things like seed stock production. And here's just a quick example that's worth sharing. If we had, for example, an ET program where we had 10 ET calves were born and they were all full brothers. So they all have 50% of the same DNA. Because they're full brothers, they're not identical. So the other 50% has come from the mums behind them. So at marking time, they're all going to have identical mid-parent EBVs with low accuracy, which basically means we know what dad's given to them, and we know mum's given them a little bit, but we're not going to know an awful lot about them because of that low level of accuracy. So how do you decide which are the bulls that you would keep to put into your program or not? And this is where genomics starts to come into play. So if we looked at the top, when we look at, and I'll come to selection indexes before we finish, but we looked at those 10 calves, they've all got the same midpoint EBV, and they've all been given a selection index of $100. So they're all the same. Genetically, we know that they're going to be different, but without knowing a little bit more information, we can't separate them. So if you were then to genomically test each of those 10 calves, what you would then start to see is which of those calves have actually got the more desirable traits that have come through more from mum rather than from dad. And that allows us then to see the range of genetic value that's being expressed across those calves. And you can see that there's calves there that have got much less than the average at about 89 versus 114. So an enormous range. And if you were thinking about which animals you would like to carry on because of their greater breeding value, if you could drop the ones with the lower value out, you would do that. The importance, but, is to remember that we need to have a reference population. And our reference population is what we have to keep going back to all the time. It's quite common for people to ask, why can't we just do genomic testing and show what traits are there or what genes are there? Well, that's fine. But until you have enough data that's driving the system, then your accuracies are going to be quite low. And this is a great graph. Jen Pert from Angus Australia used this the other day, and it really is a great example of what you would need to do. If you were looking at the accuracy of a genomic prediction, and if we take something that's reasonably heritable, so go back to that growth example that we talked about before, if it's about a 0.4 for heritability, so or say even let's go green, so something that's a bit lower in heritability, 0.3, so 30% heritable. To give ourselves a 50% accuracy, we're going to need to start genetically testing at least 8,000 animals without measurement to give ourselves enough capacity to be reasonably accurate in terms of what we're doing. So you need to have a fairly big reference population to be able to give yourselves confidence to know how accurate your predictions are based on the samples that you've taken. Small sample sizes in this 2 to 4,000 range is not going to create an awful lot of accuracy, particularly for some of those lowly heritable traits. But if you're able to add into that a link to a reference population or some other genomic information and data, you start to change that level of accuracy to something that becomes much more useful and giving you greater confidence to start to use. So when we look at then this importance, I guess, to just finish it off in terms of those questions about having a link to a reference population. Again, I'm indebted to Jen for this one, but this is from the Brahman Breedplan. So at the bull at the top, you'll see that this is a bull that's got accuracies that range from about 40% or 30% for percent normal sperm, right through to reasonably high accuracy of 69% for growth traits and so on. And so that's a bull that has been genomically tested, but is actually linked to the broader Brahman population. And because of those linkages and because of the heritabilities and the known correlations, as well as the genomic information, we've been able to generate reasonably high levels of, of accuracy across the EBVs, as well as creating a selection index. The bull below also has been genomically tested. But when you look at him, we don't have EBVs for some of the major traits that are of relevance to that particular breed. And the reason for that is that those traits are not able to be identified from that genomic test. And because there are no linkages with that animal across to the broader reference population, the generation of an EBV is going to be restricted. So for people who say, can we just test our animals? Yes, you can. But if you're not linked to the broader reference population, you're probably really missing out on the opportunity to really capture the full suite of opportunity that genomics brings to genetic evaluation. So we've got about 10 minutes to go. And where I wanted to finish off, I guess, is the other part of this, which is this concept about balanced selection and using our EBVs in a practical way. The way that I find I use my seed stock calendars and programs is to work through and actually work through the index values. And you'll see here we've got a selection, which is called a selection index values. Some breeds only have 2, some have 4 or 5. And these are measured on the potential profit expressed per cow mated across the entire profit chain of a breed. And they're based around particular market targets, because if you can imagine, if you have ever seen a Jap ox, it's very different to the lighter live export animals. So I look at the dollar index as my starting point. And the reason that I do that is because indexes have been developed by breed societies to reflect particular profit drivers for markets. And so I'm 2 slides out of kilter, so I'll go forward first to start with. So they're designed to help you balance your selection decisions, to take you away from actually thinking about single trait selection or placing far too much emphasis on traits that might then have a less desirable outcome. So when you start to have a think about that, for example, if you have a look at how that might have been developed, the breed societies use a program called Breed Object, which takes into account the market requirements and the environmental impact to then put weightings on particular genetic traits and trends to give you that outcome. So if we looked at the Angus Breeding Index as an example, the Breed Society has talked about what the key profit drivers would be for someone who is breeding replacement females and looking then to generate steers that would be suitable for grass-fed or domestic finishing programs. And the most important trait within that program, or the biggest profit driver, is cow weaning rate at 20%, followed by sale live weight, direct sales. So the progeny that are coming out of that program. Other emphasis are placed then on things such as dressing percentage, saleable meat yield, and marketing and marbling. So those are the profit drivers. They're the things that make you money within your program. If you're a person who identifies as an Angus self-replacing breeding enterprise. We then put some weighting against the EBV. So instead of you standing in a dusty set of cattle yards looking at bulls and trying to say, well, he's got so much for 400 day, but so much for 600 day, but how big is his cow weight? The index does it for you already. It places more emphasis on the traits that matter, like 600 day weight, like calving ease direct, like retail beef yield, places emphasis on shorter days to calving, and takes away some of that bigger influence on other traits so that you get a more balanced approach and identify bulls that are, on average, more suited and more balanced to that particular program. So using an index gives you a very quick and short fire way to jump straight into a catalog and look at it and rank bulls on that index that's relevant to your particular program. And those bulls are genetically displaying the best combination of traits to suit that particular market. Now, what you can do after that is really up to you. But I look at the first thing, which is making a much more balanced approach to selecting size. And you'll see that here's an example from an Angus catalogue. They've got the breeding index, they've got a domestic index, they've got a grain index, there's a grass-fed index, and so on. You can rank bulls within a catalogue based on the index that is best suited to your particular environment or in your particular market. Now, if you wanted then to place a little bit more emphasis yourself on a particular trait, you could go into that group of bulls that you've pre-ranked and resort them on your own particular traits. So if you wanted to have an animal that was still balanced for all the traits you're after, but was still a little bit lighter in birth weight and a little bit higher in calving ease because you thought you might use him over heifers, you could then find that instead of looking through 100 bulls, you've already sorted them down to 30 bulls. You can then re-rank them into 10 bulls. And what you have done is you've taken into account and you've avoided having to try and work out correlations and heritabilities and the other impacts that are occurring in the back of that genetic mix to give you the bulls that are best suited to your program. The thing with indexes is that once you actually start using them, and this again comes from Angus Australia, but here's an example that we know, given the amount of data that's been recorded by the Angus Society and Angus breeders, is that if you were to use an animal that was above the average for that index, you would start to see an improvement in calving ease, an improvement in your calving ease in your replacement heifers, a reduction in birth weight, a shortening of gestation length. But you would start to see, again, those other traits improve, like your growth traits. You would probably find that your mature cow weights are going to increase and that you'd expect that some of your carcass traits would also improve. So knowing that, you might decide that your cows are big enough already. You might look for particular bulls that are ranked well on that breeding index, but find those ones with accuracies that are reasonably high for mature cow weight, where the animals are lower than the breed average. So you're genetically now starting to shape and move things a little bit smaller over time within your herd. The other neat trick that I like to use is to use indexes to start to price new bulls. So everyone's asking me how much bulls are going to cost this year. Always a little bit of a tricky question, but you can use an index to start to generate, I guess, a price value or a break-even value of what that extra genetic improvement is likely to be worth to you over and above what the average would be for the sale or for the breed. And so that's an example of how I use it, where I find the index that suits my particular programs. And then I look at the difference between the average um, of my bull versus the breed average. And that gives me what I'd expect the bull would contribute. Multiply that over the number of cows I'd expect him to use within his working life to give me an additional break-even value where I could expect that to spend an extra $1,300 or an extra $1,400, I can actually get a genetic improvement across my herd. So it's quite a useful tool, not just to give you balanced selection, but also to give you an an improved approach to budgeting when you come to your sale. So we're getting very close to the end of time, and I'm not sure that Zoom lets us extend, but there's a couple of questions that were standouts that I wanted to come back and touch on. In terms of starting to record EBVs, what's required, compatible livestock software, and so on. Recording data, I've seen it done with using apps through to the basic True Test and Gallagher type software, other equipment that allows you to download your raw data and send it into Breedplan. Breedplan has a really good description of what you're required to do as a small producer, as well as a large producer, to start recording data. It also allows the calculation of adjustments in terms of time, whereas age of dam is not as essential for some of those other traits. And again, it will depend a little bit in terms of what you're recording. But again, we've taken out the environmental impact on that, and we're trying to look for that linkages across the breed. In terms of accuracies, we've talked a lot about that. In terms of how many animals do you need to participate and to get started, there are herds with only 30 animals that are in Breedplan. Scanning bulls to record optimum IMF, the best time. It's not really an age thing here. This is really condition score. Remember that IMF or marbling is an expression of fatness. And so you'd really be looking to try and scan your bulls and ideally scan your heifers at a point where they're in a good condition score, so that that actual trait will be expressed within the animal. Breedplan's got some really good tips on developing contemporary groups and looking at how that would actually be used. And then in terms of how can I breed bulls that are 28 kilos and 45 kilos, according to the EBVs, the 28 kilo bull has a heavier birth weight versus the 45 kilo bull. And again, that's going to come back to the data that's been collected. And I guess we're looking, if you think back to what's been collected on those particular animals and the relationships that they have from their pedigrees and their performance data that have contributed to what we know about those particular animals. Survey questions to continue. The last one, is there a way to figure out an animal's raw data from their EBVs? Not really sure that raw data is something that you need to have an awful lot of making further decisions. EBVs are designed to take away that environmental effect, which is where a lot of that raw data is going to be the result of. How important is it actually submit raw data to Breedplan, and are genetic linkages enough? Well, as we've talked about, the linkages work, but it's better to have more data in there. And is Breedplan so far behind the IGS model? I actually think it's well in front of the IGS model for lots of those reasons that we talked about before, in terms of reference populations and the relationships between that Bloop model compared to the Bolt model that IGS actually uses. So just before we finish up and I stop sharing the screen, it is really, I can't encourage you enough to spend some time having a look at the SBTS TBTS website for their technical notes. they're linked through to Breedplan, and they would be quite useful for a lot of breeders looking to try and make a start with Breedplan themselves, as well as the MLA Genetics Hub, but also the resources that many of the breed societies actually have available. So thank you for attending today. It doesn't feel like it's gone for an hour, but it certainly has. I'll stay online until Zoom kicks us off to answer any questions that might be there. But you can get in touch to follow up with questions. You can look to book a service with me at the moment, particularly for people who are looking to buy bulls, either as an agent or as an advisor. And my contact details are basically my email, which you should all have, but also my website, and Rainer Ag is on Facebook. So thank you very much for your attendance. I'll put this recording up shortly, and you'll be able to go back and look at it again. So that's about where we're actually up to. Is anybody desperate to ask any questions? If you are, please feel free to put your hand up. Otherwise, we can wrap it up about now. Thank you, Carolyn Roberts. That's quite useful. I appreciate that. Okay, question. Thanks, Joanne. Yep. Okay, well, thank you very much. We'll stop recording this now, and we will talk to you all again soon. Thank you very much.